Hi guys, welcome to the Tutoring Club. My name is Lauren and today you'll be learning about physical versus chemical change. Thank you for joining my lesson. For the remainder of time, you will be learning about how physical changes differ from chemical changes and what they both mean. Alright, to begin, I'm going to be teaching you about physical changes. Physical changes are changes in a substance without altering its chemical identity. Usually, physical changes are reversible. That means if you have a substance that undergoes a change, it can still go back to its original form. It remains the same substance, and it may change the size, shape, odor, which means smell, solubility, which means to dissolve, or state of matter. So our examples, first I have ice melting. Ice melting is considered a physical change because water is changing state. When ice melts, it goes from ice to water. But then you can always freeze the water and it can go back to ice. Since it can go back to its original form, it's considered a physical change. If it couldn't go back to its original form, however, it would be considered chemical. Secondly, cutting paper is a physical change because the paper is still paper. Just because you're changing the shape of it, which is what we discussed over here, it's still paper. It's still the same substance. And last, we have boiling water. The water doesn't change its substance, it's still water. And if you turn down the heat a little, it'll stop boiling and it will just still be the same substance. All right, I have a question and I can always help you through if you don't understand. Do you know why the snowman melting is considered a physical change?
Is it because when the snowman melts, it becomes water and we can make it into snow again?
Yes, that's perfect. That's right on the spot. Exactly what I was looking for. So when a snowman melts, it goes from a solid to a liquid. It can always go back from a liquid to a solid again. It can always freeze again. So since the change is reversible, meaning it can go back to its original form, it's considered a physical change. Are there any questions about physical changes? If not, I'll just continue. All right, next we have chemical change. Chemical changes are when substances combine to form a new substance. When a substance undergoes a chemical change, it will never go back to its original form. So unlike the snowman melting, that can go back to its original form. But chemical changes are the exact opposite and it can't go back to what it originally was. If a new substance isn't produced, it is a physical change, meaning if a new substance is produced, it's chemical. So for our first example, we have rust. When something rusts, a new substance, iron oxide, forms, and there will still be rust forever. The rust, it can't go back to its original form. Rust is going to be on it forever, and plus a new substance is forming. So that's like the key hint that it's a chemical change. Second, we have baking a cake. So after you bake a cake, it's impossible to make the cake batter again. You can't just like add water or like add something that makes the cake go back to the batter. So it's chemical. So sour milk forms that the new solid substance when the rest is liquid. So basically when you have sour milk, it's like milk that's gone bad. And it like forms like a solid substance that can never go back to liquid. Like have you ever seen those like it's like milk and then when it goes bad it just forms a solid at the bottom that can never go back to liquid. So I have another question. Why is this photo of rust considered a chemical change? And I can always help you if you don't understand.
Is it because the metal rusts, it forms a new substance called iron oxide?
Yes, that's perfect. This rust forms a new substance. When something rusts, there's always a new substance being produced. That's the key hint that it's a chemical change. And also, it can never go back to its original form. When something rusts, it stays rust forever. Are there any questions about chemical changes? If not,